Hello everybody. So I'm going to very quickly now just go through covalent bonding again. You've got your PowerPoints, which will be voice annotated by me as well to help guide you through these. Break down questions into more manageable chunks so we can build up some really detailed and good responses to the exam questions here. Alright, so we're going to start off with covalent bonding. First of all, covalent bonding always occurs between two non-metal atoms, okay? And they share their electrons in order to become energetically stable. So I've got 3 examples on here that I'm going to go through and look at with you. I'm going to start off with one that I've already finished, which is hydrogen, H2, because it's diatomic, existing pairs. This is why. Hydrogen, if you look at your periodic table, has 1 electron. So it needs to gain 1 more electron in order to get a full shell, because remember you can only fit 2 electrons in the first shell, or first energy level. So if each hydrogen shares 1 electron, you end up with this. If you look at how it's been drawn there, hopefully you can see that. A dot and a cross. This hydrogen now has 2, this hydrogen now has 2 because they've shared 1 electron each. Okay, this is quite a simple example. I'm going to look now at CO2. If you notice the way I'm drawing this up here, there's 2 lines. It's a bit like an equal sign in maths. It basically means there's a double bond. There's 2 pairs of electrons each been shared. So I'm going to draw this out here, and I'm only going to draw the outer shells just to keep it simple, otherwise it's going to look quite confusing. So how many electrons does carbon have altogether? How can I find that out? My mind's just gone completely blank. If you look at your periodic table, you'll notice that it has 6, 2 in the first shell, so there's going to be 4 in the outer shell. If it's got 4, carbon needs to gain 4 more, okay, in order to become energetically stable. So it needs to share 4 electrons altogether. 1, 2, 3, 4, and then 1. Sorry, my bad, don't need to draw anymore. And then oxygen. Can anybody tell me how many oxygen has? You've got a periodic table to hand. Even if you don't, you should know. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Oxygen has 8, 2 in the first shell. It's going to have 6 in the second shell. It's 6, it's too short of the magic 8, so it's going to need to share 2 as well. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? If you notice now then, oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Nice and stable. 4, that says 8 altogether as well, nice and stable. And the carbon also has 4 there, 4 there, 8. So this is just CO2, which we represent like this. Looks a bit scruffy actually. There we go. So CO2. Last one, again, is just a molecule of oxygen this time. Already said oxygen has 6 electrons in its outer shell. So it has 6 in its outer shell, okay? It needs to share 2. Notice how important it is to do the dots and your crosses as well, okay? Just so we know which atom the electrons are belonging to. Alright? So there's your O2 molecule, which again we can represent just like that. When we get back in, again you can mess around, not mess around, we can use the mods to model this as well. Other examples, triple bond between the nitrogen, again this has been done on your PowerPoint, I'm not going to draw that one out. But if this is a double bond, you can imagine what a triple bond would look like, okay? A bit more research for you, you can look, and again I've given you the materials for this. Diamond, why does it have such a high melting point? Why is it so hard? One of the hardest substances known to us. Graphite. Why do the layers slide over each other? Why does that help us with things like pencils, which are made with graphite? Why does it conduct electricity? What's going on there? Again, these are very specific examples. Why is graphene so useful? Why are fluorines insanely useful, especially in medicine, things like drug delivery? These are all questions, again, look through the PowerPoints that I've given you, that you can research, you can send me your answers, and I will get back to you. I might even give out some prizes for some insanely good responses. You've got to learn them off me, you know that. Okay, thank you very much, everybody.